Welcome back. So we just got done flipping a coin 3 times and listing the sample space. So before we work a problem using that sample space, we have to talk about another term, favorable outcomes. It's the outcome that you are looking for in an experiment. So, for example, if you toss a coin 3 times, how many outcomes results in 2 heads? To answer that question, you have to be able to list the sample space. Okay? And that's exactly what we did right here. Technically, you should put your answer in bracket form because it makes it a lot easier. Listing them like we did helps us create and find the sample space. Okay, so if your problem, the short answer question where you have to write out and show your work is asking you to list the sample space, always make sure you put your final answer in bracket form and separate each of the choices. Okay, to get full credit. So here we go. If you toss a coin 3 times, how many outcomes result in 2 heads? No way, again, no way can you answer that without the sample space. So here is our sample space. And again, you can see that I started with the heads, but over here, the fourth one, I accidentally switched them. That's okay. The order inside your brackets does not matter. So now, if you toss a coin 3 times, how many outcomes results in 2 heads? So you need to count how many of these outcomes, these choices, resulted in 2 heads. Okay, count them up out of how many total. So it's going to look like this. What's the probability of 2 heads? Now it could be, it's asking 2 heads. It's not asking for 3 heads. So technically you would not include the first one, HHH, because that's 3 heads, right? So count all the ones that have 2 heads. 1, 2, 3. So the probability is 3 out of 8. It's your answer. Okay, so again, it seems like a simple problem if you toss a coin 3 times, but without that sample space, the chances of you getting it right are slim because you have to know how many total possibilities are in the sample space, and there were 8, and only 3 of the outcomes had two heads, exactly 2 heads. Okay. Let's try this one. What's the probability of 2 tails? 2 tails. And I'll just put T for tails. So look at all your choices in your sample space. What's the probability of flipping 2 tails? You have to find them. Here's one. Here's one. Oh, look at that. It's also 3/8. 3 out of 8. What's the probability? I'll just do one more. What's the probability of when you flip a coin, toss a coin 3 times, how many outcomes results in only let's do this. 1 tails. Just flipping 1 tails. Look at all your choices. Where do you see 1 tails? I see one right here. I see one right here. Oh, I see one tails right here. Look at that. Also 3 out of 8. Interesting. And you could go on, make different problems, different examples. Okay. Very good. So this is, I have to be honest, this is one of my favorite um, parts of probability, the fundamental counting principle. What is it? I know you've had it in your other classes, but we are reviewing it again. You can count all possible outcomes, and you do this by, well, there's two ways. You can make a tree or simply multiply all your possible outcomes. Take a look at this one. This example, you must choose one boy out of 7 boys and one girl out of 11 girls. How many different combinations are there? Take your choices and multiply them together. And we are able to do that because if you make a tree, the bottom part of your tree, the bottom branches, add them all up, you'll get the same answer. Or if you just multiply your choices, you will get the same answer. So, using the fundamental counting principle, how many different combinations are there? 77. How? 7 times 11. Multiply your choices. Okay. Now, when you put stipulations on, it changes the problem, and we're going to talk about that in a couple lessons from now. But just using the plain old fundamental accounting principle, say you go to Fridays and you have 3 choices for your um, 3 choices for your appetizer, 5 choices for your, let me go ahead and write this up. 3 appetizers, you have 5 entrees, and you have 2 desserts. How many different combinations can you make at Fridays with your meal with 1 appetizer, 1 entree, and 1 dessert? You have 3 times 5 times 2, and that is 30 different combinations. Okay. I always like those problems to have at the restaurants. Here we go. Joe flips a coin, right? And here's your sample space. Okay. Only heads or tails. Then rolls a 6-sided die. Well, there's 6 sides, so your 6 choices are either 1, 2, 3, 4, 5, and 6. How many possible outcomes are in the sample space of this experiment? Okay, so you flip a coin first and then you roll a die. What are your combinations? What are your possibilities? Well, let's just talk about it. You could get a heads with and then roll a 1. You could get a heads and roll a 2. You could get a head. That's a lot of work, right? Multiply. 2 choices when you flip a coin. 6 choices when you roll a die. 2 times 6 is 12. Oop, 2 times 6 is 12. Excellent. So that is the fundamental counting principle. You could also make a tree diagram, but that's time consuming. Use the fundamental counting principle where you just simply multiply. Okay, multiply your choices. You have a wonderful day. You are ready for the lesson 1 quick check. Please make sure you rewind, go back into part 1 if you need to, and take notes, take screenshots, and use your notes on your assignments, and have a wonderful day. Thank you.